Hello guys, I'm Peter from Builder Boeing. I'm out here in the workshop and it's so cold out here. It's freezing outside. It's around -3 or 4 degrees centigrade, that is. But it's still cold, there's no heating out here. So I'm wearing a thick jumper, and actually my wife was just so sweet that she came by with a cup of, well, we call it Glück. It's hot wine, Glühwein in Germany, I reckon. And it's needed out here because it is so cold. Anyway, we're not here to talk about the temperatures in Denmark. We're here to talk about my plans for 2023, which March had something called Yoke Quick and Dirty. And here it is, the Quick and Dirty Yoke. It's not March right now, it's December very shortly. So all that January, February making the main instrument panel, boy, that has taken forever. Here we are, November, and the Quick and Dirty Yoke is done. And when I say quick and dirty, the plan was, and what I've done is, I've went into the workshop here and I saw what I had laying around, and then I made something from that. So I've not planned it, I've not bought a lot of things. It was just things that I had laying around. If I was to plan it, I would probably have done it in a different way, but I'd still learn some things here that perhaps you can benefit from. So let's just take it from the top down, I reckon, and you can see how you can do this if you want to make a yoke quick and dirty. The yoke itself is an Acron yoke, but that really doesn't matter because whatever you got going, if it's 3D printed on another yoke or just a piece of plywood that you cut out to look like a yoke, what's important is, of course, you need to mount it somehow. And I've used a 10mm rod here. It came with this massive 3cm rod, 30mm rod that goes through a tube actually. And just take a look down here. It came also with bearings. And this is the original bearing that came with the yoke. And I just put my hand next to it, and you can see it is a massive unit. It's, I don't know, about 10 centimeters from here to here. It's just massive. And my first attempts at getting it mounted into a beam of some sort, you just see how wide it is. That was never going to happen. So I remade a locking mechanism here for the yoke, and that's what I'm saying. Depending on which yoke you're using, you just need to figure out something here to get a rod mounted onto it. A bit of bearings here to keep it in place, and then on the back here a pulley belt, as you know them from 3D printers. And on the pulley belt here, I got these two wheels here. When I turn the yoke, you can see they move. It's just to keep it narrow here because it goes down here to another wheel, which includes a potentiometer. So there's a potentiometer here, which means when I turn the yoke, the potentiometer turns. To keep it in place, down here, well, springs. Really not much going on there. 2 springs on each side. These are from, we have these lamps here in Denmark. We call them architect lamps. I'm sure we've got them all over the world. They're like 2 folded, and they have springs on the side here to keep them in place. So springs from lamps, very easy. And you can see when I turn the yoke, the springs go up and down. It's a bit going back and forth, but it's okay for me for now. And it levels again. So that's the yoke, the turning of the ailerons. So that was the aileron. The other thing is the elevator. This one going back and forth and having it coming back to the same position. If you look at from the side here, you see if I pull it forward, it goes back to the same 8 degrees. It has to be 8 degrees, and if I pull it back, it comes back to the same position. That took a lot of time, and of course it's mounted here on a stick, and all the mechanism is down here. And let me just show you what's going on down here. The very first thing I did was to mount some gas dampers. This one is 80 Newton, and the reason for the dampers was to give a bit of resistance when you move the yoke, so it didn't move that easy. Furthermore, when I pull the yoke backwards, you can see this part hits this part, which limits the travel of the yoke. So making the yoke stop at the right position is achieved by this not going any further. That's how I limited the travel of the yoke to those -4 degrees. And on the opposite side, you can see a damper right there. Now this is mirrored, so what's going on here is also going on here, and what's going on over here is going on here. But I'll get back to this one in a second. So this damper is just restricting how fast you can move the yoke, and it is also restricting the movement so you have the right angle. Getting this back in place at these 8 degrees, I used springs. I had a spring connected from here to here and in the other direction. You cannot use a damper like this because a damper delivers the same pressure no matter if it's fully extended or fully retracted. It delivers those 80 newtons. So if you just use dampers, it's not going to go back to the center position. It's just going to stay in place because it has the same force in both directions. Whereas a spring, the longer it gets, the more tension it has, the more force it pulls with. I hope that makes sense. So I tried with springs going from here and back here and the other way. And that just didn't work out. When I pulled the yoke that way, the springs, of course, would pull it back to the 8 degrees. But when I pulled it forward, it wouldn't go back to the 8 degrees. It would perhaps just stay a bit further down. But as you don't have that much, now watch from here, from this angle to the maximum, this angle, there's not a lot of room going on there. And having it not coming back to exactly 8 degrees, but perhaps here would be, let's say 11 degrees instead of there. That's 1/3 of the entire distance that this can travel. So the aircraft would think that your elevators would be 1/3 down. That wouldn't work. So I had to come up with something different, and I got inspiration from other people. That's always a very good idea. Can you see this piece of wood right there? Hope you can see that. That is mounted with these 2 screws, so it doesn't go anywhere. And it stops this one. So this piece of wood is connected to this. So you can see it up here. There it is. It just goes down here. And it is mounted now with a gas spring, but I'll get back to the gas spring in a few seconds. And you can see if I pull the yoke backwards, it moves back, okay? But it's stopped right there. So it stops there, it stops right there because they meet. But when I pull the yoke the other direction, it doesn't move because it stopped right there. Okay, this makes sense. Going back, going forward. And the same thing is going on over here. As I said, it's mirrored on the other side. Okay, and this keeps it in place. And of course, this piece of wood down here needs to be angled at the 8 degrees. Otherwise, it will not work. But when you get this at the 8 degrees, and it acts as a stopper for these 2 levers, it always goes back to the correct. It always goes back to the correct angle. And look, mosquito, November. I tried with springs again. I thought I should use springs all the way through. Apparently not. I tried with springs going from here and then pulled it back over here. But again, 2 springs to keep it, to have enough force to pull it back. And 2 springs going over here around these. It was just a hassle and it started getting in the way. So luckily I had an extra set of dampers laying around. And this is 100 Newton. And they apply quite a lot of force. So when I move this one pushes it back until it hits the stop up there. And that's how I achieved getting this in the very correct position. Next up, I just need to get a saw and cut it here so it doesn't go as deep. I don't need all this down here. This is just for working. And once that's done, I'm actually more or less finished. There's a bit of wiring I need to do, and perhaps you're able to see this one right here goes up to an arm there, and you can see when I move the elevator, the arm moves. That's the potentiometer. Up here is the potentiometer for, let's see if we can have a look down here. right there you can see the potentiometer, and when I move the arm with the potentiometer up and down. So this is my take on a quick and dirty yoke. And by quick and dirty, I mean going into the workshop, putting whatever you have together and get something that works at the end. Pretty cool. Took me about a week to make, and I'm looking forward to getting it mounted in the cockpit in a few days. I just need to interface it. But the thing is, I didn't have a master plan. I didn't have a grand drawing. I didn't buy anything in advance. This is what I had laying around. The other way would be to get planned ahead, and then I would probably buy drawings for the dual connected yoke. There's a guy in England selling those. His name is Carl. You probably know him. And that would be a totally different project, because I would be printing for 2 months. I'll be buying things for hundreds of dollars of eBay to put together, and I needed some metal welding, and it would take a longer time. This was 1 week for things I had laying around. That's the difference. At a later point, I reckon I'll go to dual connected, but for now, this is going to work. So if you are looking for a yoke, you don't need a fancy aluminium cast. You can just go with, MDF with just a few pieces of sticks put together. It doesn't matter. It's just a matter of getting into the workshop, getting it on a long stick so it goes back and forth, and then get it into your cockpit. And then you're off. Sometimes it's just a matter of getting things done to begin with at bare minimum, and then at a later point we can start gold plating. In the following weeks, I did spend some time finishing up the project. I found some tube and put it around the yoke, and then mounting it in the cockpit took a bit longer than I anticipated. But finally, here we are, March, check mark, done. Feels great. So I hope you can use this as inspiration for getting into your workshop and start making a yoke. Otherwise, you just wasted 10 minutes. Anyway. Hope to see you at a later point. I'm Peter from Boeing. You guys take care. Bye-bye.